No problem. Okay, so today I will discuss the module 6. Module 6. Okay, so that is kinematics and kinetics. Right? Kinematics and kinetics. So, in kinematics, what is the meaning? Kinematics, basically, this discusses the motion parameters. Motion parameters. What are the motion parameters? Basically, first displacement, then velocity, then acceleration. So, displacement, then velocity. Displacement is denoted with S, then velocity. Velocity is V, and acceleration. Okay. Velocity V is basically dsdt, rate of change of displacement, and acceleration is dv that is basically d2s dt2. That means rate of change of velocity, or this is rate of change of displacement. Rate of change of displacement. What is that? Basically, if you write acceleration is equal to dg dt is equal to ddt of v, and what is v? ds dt. So that is rate of change of displacement, isn't it? Rate of change of displacement, and v is simply ds dt. We are writing in terms of scalars here because we are considering that it is a component, because velocity can be a component. So if it is a rectilinear translation, that means one dimensional, then you can simply write in terms of components. Otherwise, you can write in terms of vectors. Okay? That means because vector has components, so you can decompose it in terms of components, or you can write in terms of scalars if it is rectilinear translation. Okay. So discusses the motion parameters without discussion of force. Without discussion of force. Force causing the displacement, causing the motion. What is the meaning is that force actually causes motion, right? From Newton's second law, we will discuss that first law, second law. So what is first law? Newton's first law. That means if you have some motion condition, that motion condition will not be altered if there is no external force acting on the object. Okay, that means unless acted upon by external force, the moving object will keep on moving with constant velocity, and the static object will be in rest forever. Right? So that means they will continue to uh, that means if it is moving, continue to be in their own motion condition. That means unless acted upon by external force, then if some object is moving, then it will continue to move with the velocity, same velocity, constant velocity. And if one object is at rest, then it will continue to be at rest. Then velocity is 0. That means what? If you have no external force, that means if the external sum of all external force is 0, that means first one. Newton's law. First law. So that means if you have that is 0, if it is 0, then the motion condition will be unaltered, right? So unless acted upon by external forces, the object which is moving will continue to move with constant velocity, and the object which is at rest, it will continue to be at rest. That is first law. So if this is 0, then acceleration is 0. That is the meaning. That means either it will move with constant velocity, either velocity is constant or velocity is 0. For moving objects, and for objects at rest, right? So before application of force, if one object was moving, then it will move with constant velocity, and if one object was at rest, it will continue to be at rest. That is first one. Okay. So this is important. Right? If the second law, what is second law? Second law is saying that if there is some force which is non-zero, second law is saying that if there is some force which is non-zero, then the rate of change of momentum, linear momentum, will be proportional to that force. Okay, so that means if there is unbalanced force or resultant force, or rate of better the version is the rate of change of angular momentum, rate of change of linear momentum of an object is proportional to the force that is applied force on it, right? So rate of change of linear momentum, rate of change, let me write it somewhere. First law, then second law. Second law. What is that? If this is not zero, if this is not zero, then so that means that force is equal to mass into V, but ddt of that. Right? So if the mass is constant, then mass can be taken out. So it will be m dv dt, and therefore you can write m into a. Isn't it? So it's telling that the rate of change of angular momentum You can write the rate of change of angular momentum is proportional to the applied force, and the rate of change of angular momentum actually happens in the same direction as that of the resultant force. So rate of change of angular momentum is proportional to the applied resultant force. This is the resultant force obviously, right? And it will act in the same direction as that of the applied force. Clear? Is it clear? Rate of change of linear momentum is proportional to the applied resultant force, and they will act in the same direction because this is the vector. So this vector and this vector, if they are equal, then the direction of them are same. Right? So that means if it is only one dimension, then you can directly have one dimension. So you can write in terms of components. Otherwise, what we can write, if it is a vector, then we can write that f is equal to m dv dt or equal to m a. Clear? Okay. Now, if it is a vector, then you can decompose the vector. So you can decompose this vector as well as you can decompose this vector. Isn't it? So that means what will happen? You can write that for this, if I decompose this vector, if I decompose this vector into three directions, what it will be? Summation fx is equal to this m ax summation fy is equal to m ay summation fz is equal to m az. If I decompose this in terms of three components, I will decompose this in terms of three components. If you decompose this in two components, then it will be only two components. And if it is only one dimensional, then you have only one. Clear or not? So this is the second law. That means the rate of change of angular momentum. Since there was no change in momentum in the first law, so resultant force was zero. Therefore, no change of momentum. For second law, the rate of change of linear momentum is proportional to the applied resultant force, and they will happen in the same direction. Clear? The third law is stating that each action will have equal and opposite reactions. Right? So that means what? First law, second law, do you understand? Right? That means if one object is static, if there is no force on it, that means if the resultant force is zero, maybe there are forces like, say for example, this object, it is stable on this. So there are two forces. One is downward, that is active force. Another is upward, that is reaction. So for this, two forces are in equilibrium, isn't it? Two forces are in equilibrium. Therefore, the resultant force is zero. Therefore, it will be continued to be at rest. Clear? Now, if it were moving, then it will continue to move with the same velocity because there is no resultant applied force. So it will be, the velocity will be constant. Two cases, right? One is constant velocity, another is zero velocity. That will be constant forward because moving, so it will continue to move with constant velocity. If it is already at rest, it will continue to be at rest. Right? This is the case where it is at, that means this first law is a special case of second law. Isn't it? In the second law, this is basically non-zero. Right? So here it is how the rate is varying, how the momentum, angular linear momentum is varying. That is basically proportional to the force. Right? That means if it is zero, then it is zero. That is the case. So first law is a special case of second law. Clear? Third law tells that if you have one object, that means you see any object. Say for example, I am trying to push this. I am trying to push this. Then it will also give me a back push. All in all situations. That means whenever two objects are interacting, then there will be equal and opposite reaction. Action and reaction will be on different objects. That you have to understand. Action and reaction will be on different objects. That means when I am, say for example, I am pushing this, so I am acting on it, so that is a force, and the reaction will be on me by this. That means I am applying a force on this, that is action, and reaction is given by this object on me. So reaction will be on me, right? So action and reaction will be on different objects. That you have to understand. That means when I push this object in the free body diagram, this is the action. So action will be on this, but reaction will be on when I am showing my free body diagram. Say for example, one person is, say for example, say one object is there. Okay, one person is pushing, right? Pushing. So this is the force. This is the force. He is pushing. Next, that means when I will draw the free body diagram of this, there will be a push. So when I draw the free body diagram, can I erase it? Partly. Because means third law is mostly misunderstood. Although it's very easy. Friction will be different. Means there are many reactions. For all actions there is reaction. For all actions there is reaction. Because that is why third law is mostly misunderstood. It is not understood properly, and many problems are becoming, the solution of many problems becomes wrong due to misunderstanding. Okay, I will show you. So that means this is the object. How it is interacting? It is interacting with this person as well as with this object. So that means here there will be action by this on this, and there will be reaction by this on this. Again, there is action by this on this, therefore there will be reaction by this on this. Clear? That is the thing. So there will be two objects. One is this one, another is this one of person. Okay, and it can be this one also. Okay. Now what we do? Free body diagram. Of the block of the block, right? So what is that? If I draw the free body diagram, then I will show weight of this. This is the weight. Is acting from this, and there will be a reaction from this, right? So, for example, this is W. Weight is W. So weight is W. So you can write it is equal to mg. And there will be reaction, normal reaction, say N. Right? So this is actually weight. This is actually weight. N is the reaction by this. Okay. Next one is when this is say P. This force is a P. So there will be a P on this. This is the force by the person on the block. Right? So there are three forces. One is this force applied by the person, another is the weight due to gravity, another is the reaction by the surface. Clear? Reaction by the surface. Okay. Now under this, the object, again there will be a friction. So if it is pushed by this, then there will be a friction. Basically, this reaction during the discussion of friction, I have shown that this reaction is basically, the actual reaction is the resultant of these two, isn't it? So it will be basically resultant of these two means it will be in this direction. So that is say R. So this is the resultant of this and this, right? In the during the discussion of friction, I have shown. So it is the surface reaction. It is also the surface reaction. This is normal and this is tangential, and the resultant is this, right? Okay. Now, if I want to show the free body diagram of this person, so can you show it? Say for example, it is pushing. Right? So what will that be? What will be the resultant? Can you show? Resultant means the forces. You see, this will be the force by the block on this person. Same force P. Negative direction if it is there. Okay? And there will be what? There will be weight of this person. Right? Say weight of the man means suffix, right? This is weight of the man. And then what? There will be reaction. What reaction? By the surface. By the surface. So it is in which direction? It is in this direction. Because by the foot, it is trying to force the plane in the backward direction. So the plane is now supporting me in the forward direction by this push. So this is by the plane, that is the horizontal surface floor. So this is the surface, and there will be a normal reaction. Normal reaction factor. So this is the friction, and there will be a normal reaction. So this is normal reaction, say N on man, and this is the friction by the floor on the man. Clear? So basically again the reaction is because I am pushing in this direction. When I am pushing by the foot, say how I am pushing, say this is this, right? This is the shoe. So I am pushing in this direction. When I am pushing, how I am pushing physically? By this way, that means I am pushing in this direction. By angle. By making an angle. This is this. And the reaction is in which direction? Reaction is opposite to that. So this has two components. One is this, another is this. This has two components. This is the reaction by the floor on me. This is the reaction by the floor on me, and it has two components. One is friction and another is normal reaction. This is the action by me on the floor. So I am pushing the floor in this direction, in an angular direction, and the floor is pushing me back in the angular direction, same angular direction. It has two components. For our convenience, we have decomposed it into components. One is tangential, that is friction, another is normal reaction. Clear? So this has two components. One is this, another is this. Clear? Is it clear? That means, you see, when I show this force, I will show this force. Because they are equal and opposite pair. According to Newton's first law, they are equal and opposite pair. Is it clear? So according to Newton's third law, if the action has equal and opposite reaction, and they will be collinear, obviously. Equal, opposite, collinear. Right? That means internally all the forces are balanced. Internal. So internal forces all are balanced. You see, this one is same as this. The resultant of this is same as this. That means this. So this percent, that is the action by me on the floor, and this is the action by the floor on me. So when I show the free body diagram, can you tell what force will be shown out of these two? When I draw the free body diagram of my foot, out of these two, which force I will show? That is basically conceptual part. That is the conceptual. Out of these two, I will show only one because these two will balance each other and they are basically collinear. And also I have shown it separated. They are basically collinear. So which one I will show and which one I will not show? White one. Not this one. Pink one because that is the force on B. So I will show the forces on B. When I will draw the free body diagram, all the forces on B I will show. Right? So that is the force on B that I will show. This is the force by B on the floor. So when I will draw the free body diagram on the floor, then I will show that. Okay? Now, if I show the free body diagram on the floor, what forces I will show? Can you tell? Velocity? Newton's thought is very conceptual. Very much conceptual. Most misunderstanding and means error comes from this. What forces I will show? Can you tell me? For this floor. If I try to show the free body diagram of the floor, at least for this part, what forces I will show? This one, two, only these two, right? And here, these two, only. If I consider its weight, then you have weight. Okay. Otherwise, these two will come and these two will come. Is it clear? Clear? 29. Is it clear? Yes. So this force will be there. Now it will be in opposite direction. So this will be in opposite direction, isn't it? Now you see that this will be in opposite direction. So this will be in opposite direction. This will be in opposite direction. So this will be like this. Clear? This will be in opposite direction. Which direction? This one? Normal. This one. Same normal. N. Just like this. Pair. So N will be in opposite direction. What will be the direction? Opposite direction. So it will be in opposite direction. So if it is a friction on the block and normal reaction on the block, okay, normal reaction on the block, so it will be NB in this direction and NB in the reverse direction. Because action and reaction are opposite and equal. So it is equal but opposite. So every action and reaction pair will be equal and opposite always. Clear? And it will be on the different object. That means action is on this, but reaction will be on this. Clear? So this is MP and this is NP. And what is this? This is say NM on the man. Then by the man. This is by the man. And this is FM. Clear? Is it clear? So whenever you have say some blocks or means many blocks, 2-3 blocks are there, right? So you draw the free body diagrams like this. So that their application of Newton's theorem is very important, very crucial. Okay, clear? I can give more examples, but it takes time definitely. So the second one is clear. First one is clear. Third one I am discussing. I may discuss some more examples so that it will be clear to you. Okay. Say for example, if you have say two objects. So it is connected here and you are pulling it. Right? Yeah. So free body diagram. Let us draw the free body diagram. So during drawing free body diagram, third one becomes very important. Yeah. So so say for example this is a W1 and this is W2 weights. Okay, and the coefficient of friction is a mu s for all subjects, all contacting surfaces, mu s. and this is here. So it is say some angle given, say it is a alpha. Okay, alpha angle is alpha. Okay. So free body diagram. FBD of W1. What will that be? FBD of W1. FBD of W1. So there will be tension. I push it, I pull it. So E will try to be pulled, and accordingly it will drag this one also. So it will drag this. So there will be a tension here. Therefore, T. Okay. And it has weight, so W will be there. Whatever we know immediately we will draw. So it will be W1. Okay. Now on this, there will be normal reaction by this. So normal reaction by this. So say this is N1. Okay. And since I pull it, I pull this. Say this is a P. I pull this, so there will be friction on this. So what will be the direction of friction? Can you tell? It is trying to be moved in this direction. So it will try to move this object also in this direction, but it is fixed. So relating to this, it will try to move in this direction, right? So what will be the direction of friction on this? It will try to move, so friction will be on this. The friction will be in this direction because this is trying to move this object. So at that point, so this is fixed. This is fixed. So since it is trying to move in this direction, so it will, or this object will try to move this block in this direction. Therefore, friction force will be on this direction, on this. Clear or not? Is it clear? So the friction on this will be in this direction. So the direction in which it is trying to be pulled. So what is actually pulling this? Can you tell? Means this is pulling this block via friction. Using friction only. There is no other connection. Right? So by friction it is pulling.